Task number 5. Cryptographic failures. We are inside the WASP Top 10 2021 from TryHackMe, which is inside the Complete Beginner Path. Cryptographic failures. A cryptographic failure refers to any vulnerability arising from the misuse or lack of use of cryptographic algorithms for protecting sensitive information. Web applications require cryptography to provide confidentiality for their user at many levels. Take, for example, a secure email application. When you're accessing your email account using your browser, you want to be sure that the communications between you and the server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email address. When we encrypt the network traffic between the client and a server, we usually refer to this as encrypting data in transit. Since your email are stored in some server managed by your provider, it is also desirable that the email provider can't read their client's emails. To this end, your emails might also be encrypted when stored on the server. This is referred to as encryption data at rest. Cryptographic failures often end up in web apps accidentally divulging sensitive data. This is often data directly linked to customers, which are names, births, sensitive information, right? But it could also be more technical information such as username and passwords. At more complex levels, taking advantage of some cryptographic failures often involves techniques such as man-in-the-middle attacks, whereby the attacker would force user connections to a device they control. Then they would take advantage of weak encryption on any transmitted data to access the intercepted information, if the data is even encrypted in the first place. Of course, many examples are much simpler, and vulnerabilities can be found in web apps that can be exploited without advanced networking knowledge. Indeed, in some cases, the sensitive data can be found directly on the web server itself. The application in this box contains one such vulnerability. To continue, read through the supporting material in the following task. Answer the questions below. Read the instruction to cryptographic failure and deploy the machine. Perfect. Now, jumping on WASP website, we have the second vulnerability, cryptographic failures. Right here, we see an overview of some statistics on how often was seen, how many apps were vulnerable from tests, and so on. And we have 3 example scenarios. In first scenario, we have an application which encrypts credit card numbers in a database using automatic database encryption. However, this data is automatically decrypted when retrieved, allowing a SQL injection flaw to retrieve credit card numbers in clear text. Well, it's a more nuanced than this, but let's take this example as is. In the scenario number 2, we have a site which doesn't use or enforce TLS for all pages or supports weak encryption, meaning that we can see the traffic. An attacker monitors network traffic, for example, at an insecure wireless network, downgrades connections from HTTP to HTTPS to HTTP, intercept requests, and steals the user's session cookie. The attacker then replaces this cookie and hijacks the user authenticated session, accessing or modifying the user's private data. Instead of the above, they could alter all transported data, for example, the recipient of a money transfer. And in scenario number 3, the password database uses unsalted or simple hashes to store everyone's password. The file upload flow allows an attacker to retrieve the password database. All the unsalted hashes can be exposed with a rainbow table of pre-calculated hashes. Hashes generated by simple or fast hash functions may be cracked by GPUs even if they were salted. What is a hash? Well, a hash is basically, if we take the context of a password inside the database, a password is just clear text, right? It's just a string. A hash is basically applied to your string to create your password, which is in clear text, to create it with a fixed length, basically string. A salted hash is basically added after the hash is added extra randomness to your hash so that your hash is very, let's say, unique. Well, a rainbow attack basically is, you can see it here with pre-calculated hashes, is basically doing some matches to try to see if some pre-calculated hash matches something from the database that is stored.